Assalamualaikum and hi. We are from Group 7 from Section 02. Today we would like to share about the presentation of our Mechanical Laboratory 2. I am Norfazin binti Arifan with ID number MH20032. I would like to introduce about the fundamental of machining. The introduction of fundamental on machining. Machining is the process of removing metal from a workpiece using various of ways. Mechanical mass reduction processes are the most prevalent, including the removal of chips in the form of ribbons or particles of various forms and shapes. Features such as smooth gleaming surfaces, small diameter dip holes on a product, threaded section, and threaded holes all need additional manufacturing process. For our mechanical laboratory too, we are going to do the milling process. Milling machines is generally held in a vise or similar device secured to a table that can move in 3 perpendicular directions, and the milling machines rotates a circular tool with several cutting blades symmetrically positioned about its axis. There are many types of the milling machines that being used all over the world, but in this project of laboratory, we are being using two types of milling machine, that is vertical milling machines and the horizontal milling machine. This is the types of the milling machine, that is the horizontal milling machine and the vertical milling machine. Let's see what is the difference between these two milling machines. For the horizontal milling machine, it has a spindle rotates parallel to the table. This machine table moves along the three axes, that is X, Y, and Z. Cutter that being used are the slab milling cutter, side and the face cutter, and the slitting saw. For the vertical milling machines, it has a spindle rotates perpendicular to the table. Milling head can be adjusted in different angle, and cutter that being used are the end mill cutter and the face mill cutter. The tool material. There are several tools that being used in the laboratory, that is high-speed steel, carbide, ceramic and diamond cutting tools, vise, and the cutting fluid. The high-speed steel is used as cutting tools and have high alloy steel till. It is an alloy of iron, chromium, nickel, cobalt, and some molybdenum. Goods for grinding and permits regrinding of blunt tools. Next is carbide. Carbide is a compound composed of carbon and less electronegative element. It usually a metal or metal oxide. Usually used in manufacturing purposes for tracking, make bolts and cleats. Also being used in mechanisms that require cutting and pulverizing. Next is ceramic and diamond cutting tools. They are hard and can retain the hardness even at high temperature. They also have low reactivity with steel and can be used at high cutting speed without deformation. Vise is a device consisting of two parallel jaws for holding a workpiece. The jaw can be fixed and permanently bolted to a blunt. The cutting fluid is a lubricant is being used to reduce the friction between workpiece and cutting tools. Cutting fluids also being used to minimize the heat generation rate and for lubricant purposes. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fikir bin Maksha. My matrix number is MH20029. Today I would like to present about machining methodology or technique and machine setting. For machining methodology, there are two basic milling methods, which is plane milling and end milling. Plane milling is the milling process of a flat surface with the parallel axis of the cutter to the machining surface. It can be operated either on a vertical or a horizontal milling machine. For end milling is a milling of a flat surface with the axis of the cutter perpendicular to the machining surface. For machine setting, first I would like to present about 10 milling techniques in sequence. First, facing process, followed by edge finder, stepping process. Fourth is center drill. Fifth is drilling process. Next is counter bore. Then followed by tapping process, slotting process, chamfering process, and the final is final product. So we proceed to the machining setting. So there are 4 requirements that we need to find for machine setting. First is feed rate. We need to calculate the feed rate. Second is tool that we use in this process. Third is cutting speed selection, and fourth is the RPM. So for the first process is facing process. So as you can see, this is the feed rate calculation that I have been done, and this is the tools for this process, which is animate 20 mm of the diameter. The cutting speed selection, we can use 150 meter over minute, and the RPM cutting select for the RPM, we use this formula and we can get this RPM. Next, for edge finder, the feed rate we don't need to calculate, because since it's just to find the edges of the workpiece, we don't need to find the feed rate. So the tools that we use in this progress is edge finder with 10 millimeter diameter. So for the cutting speed, here we use 13 meter over minute. For the RPM, we just put in the all the information in the formula, and we can get the RPM. For stepping process, the tools that we use is end mill with 20 millimeter diameter, and the cutting speed that we use is 150 meter over minute. For the feed rate and also RPM, we just put in all the information that we have into the formula. For center drill, we use center drill tools which are 3 millimeter diameter. For cutting speed selection, we use 40 meter over minute, and the RPM and feed rate, we just put all the information that we have, and we can get the RPM and also the feed rate. For drilling process, since we have two different holes that we need to drill, we use first drill 10.8 millimeter for M10, and also drill 8.8 millimeter for M8. So the cutting speed both is same, which is 40 meter over minute, and we need to find for each drill throughs, feed rate, and also the RPM, so we can get a different result of RPM and also feed rate. Next, for counter bore, we use counter bore M8 with 8.8 millimeter diameter, and we use 40 meter over minute for the cutting speed. So we just put in all the information that we have to find RPM and also feed rate. For tapping process, we just use tapping tools M10. So we don't need to find the feed rate and also RPM. For the second last process is slotting process. For sorting process, we use end mill tools with 8 millimeter diameters, and we use 60 meter over minute for cutting speed selection. So the feed rate and also RPM, we just put in all the information that we have to the formula. Last but not least, for chamfering process, we use chamfering tools 45 degree, and also the cutting speed we choose 77 meter over minute. Then we can get the RPM, also feed rate, when we put all the information into the formula. That's all for me. Thank you.
Hi and Assalamualaikum everyone. My name is Muhammad Ziki Manuddin bin Zuhairi. My metric number is MH20028, and today I will be presenting about machine handling and safety precaution for BMM 1821 Mechanical Lab 1. The first part is about machine handling. There are three parts for milling process, which are before we start milling, during and after the milling process. Before we start milling, we must clamp securely our work in a vise and clamp it tightly. We also need to make sure the cutter is rotating in the right direction. Before we run the milling machine, we need to check the spindle to make sure it is smooth, and we need to make sure to turn off the power of the machine before changing cutters to avoid any injury due to the machine. We also need to use the proper cutting fluid for the material being cut, and we need to use sharp cutter and in a good condition. If at all feasible, rig a guard or shield to prevent chips from hitting other people. And lastly, we need to wear personal protective equipment, or also known as PPE, such as hand glove or goggle. During milling process, we need to run the machine with correct cutting speed. We are not allowed to let the machine running itself without control, or in other words, leave the machine unattended. It is very dangerous in case the machines become malfunction. Next, don't take too heavy a cut or use too rapid a feed. The machine also should not be operated by more than one person. If there have any emergency, we need to stop the machine immediately and don't feed it by ourselves. We need to report to the technician as soon as possible. After finishing milling process, we need to make sure that the machine is fully stopped before taking any measurement to avoid any injury. We need to use milling machine spindle brake to stop the spindle after the power has been turned off. Before cleaning the machine, remove cutting tools from the spindle to avoid cutting ourselves. Let's move on to the next part, which is personal and general laboratory precautions. The first one is we need to wear appropriate clothes during doing the lab work. We need to wear gloves, laboratory coats, and safety shield or glasses. Shorts and sandals should not be worn in the lab at any time. And if we have a long hair or loose clothes, we need to make sure it is tied back or confined. We also should not use any equipment unless we are trained and approved as a user by our supervisor. And if we are leaving a lab unattended, we need to turn off all ignition sources and lock the doors. In case of equipment failure, for example, if a piece of equipment fails while being used, we need to report it immediately to our lab assistant or tutor. Other than that, we need to wash hands before leaving the lab and before eating. Other than that, we also need to maintain unobstructed access to all exits, fire extinguisher, electrical panels, emergency shower, and eye washers in case of any emergency. We also should not use any corridor for storage or work areas. Other than that, we should not store heavy items above the table height. Any overhead storage of supplies on top of cabinet should be limited to lightweight items only, to avoid any injury if they fall to our body parts. Also, remember that a 36-meter diameter area around fire sprinkler heads must be kept clear at all times. And the last one is, we need to be careful when lifting heavy objects. Remember to lift comfortably, avoid unnecessary bending, twisting, reaching out, excessive weight, lift gradually, and keep in good physical shape. As a summary for our Mechanical Lab 1 session, we get to know how to properly operate the milling machine, and we get to know how to use the pieces in the milling machine. We also realize that safety is very vital before operating any machine in order to avoid any injuries. The laboratory lesson also taught us about the several types of cutters that are used in the milling process. We gain a lot of knowledge of the uses and function of the machine, which can manufacture various shapes of workpieces with various surfaces. We also get to understand how to compute RPM, cutting speed, feed rate, spindle speed, and also the usage of cutting fluid. And the measure of this project is to help the student enhance his or her skills and confidence.